trig equation means you're solving for the angles. Okay, so again, check with 5 pi over 3. And if you kind of see it over here, 5 pi over 3, if this is 6 pi over, if this is 3 pi over 3, and this is 6 pi over 3, you're here, you're still where cosine is positive. So if you saw that there, absolutely. If you plugged it into your calculator, absolutely. I would just put my calculator in radians and just put the angle in. Can you put it in degrees? Absolutely, you could do that too. Then you had to check these guys. Again, secant is the reciprocal, so if you find your secant and you turn it over, there's your cosine 1/2. It was the same problem as the one before it. Did you notice that? Well, yeah. Checking it wise. Well, probably because you just throw it in your calculator, right? So you can put it in your calculator and absolutely check it. But it was kind of like the same problem. Now we get to solutions. So you're going to solve an equation for the sine of x, and then you're going to tell me where from 0 to 2 pi is sine negative. Drop your triangles, find your angles, and because this is all solutions, and when you solve, we automatically go to all solutions. Because your curve is endless, your cycles are endless, so always give me all solutions. So plus 2n pi, plus 2n pi, plus 2n pi, where n is any integer. Make sure you say this. Questions? Stop me if you have any questions. We did the kind of basic ones. Today we're going to do a little bit more difficult equations. Equations that have factoring and some things we have to substitute in. But these were kind of like just your basic. And they're going to be your special right triangles. Otherwise you'd need your calculator to find your reference angle. And you can absolutely do one that's not a special right triangle. You just have to pick up your calculator to find your reference angle. Again, so here's the sine is negative. Sines use y. Where's y negative? It's the bottom two quadrants. So drop your triangle and find your angles. Good? Okay. Secant is the reciprocal of cosine. Cosine is positive in 1 and 4. You can do r over x, or you can flip that over, do x over r, whatever makes it easier for you to see it. Sometimes I find if you flip it to take one of the basic 3, you recognize your triangle a little faster. Like radical 3 over 2, you recognize that a little faster than 2 over radical 3. Which other one? No, because what happens in number 32? You get 2 of them. You get x is equal to 3 pi over 4, and you get x is equal to 7 pi over 4. But aren't these across from each other? Straight across 180? Yeah. So if I do n pi, don't I hit the 7?
So, but I thought you had to put the 7 pi plus n pi back to the 3.
No, just do the first one. Do the ones that are opposite each other. If you do this plus 2n pi.
So all you have to do with that is the first one?
Yeah, well, the ones that are opposite each other. The first one you hit opposite each other. So this one, if I add pi to this, so if I'm here at 3 pi over 4, and I add pi, so let's convert this to fourths. Don't I get 7?
Yeah.
I get this guy, and I get 11, and so forth, and it'll keep on going.
So
because,
I'm sorry.
go ahead.
So it would be wrong if you put 7 pi over 4?
Well, I said yesterday, this is technically not wrong, but I would like you to try to see that when they're opposite each other, to do plus the n pi.
What if you, because I just put 3 pi over 4 plus n pi, but then I also put 7 pi over 4 plus n pi.
So if you do 7 pi over 4 plus n pi, you're basically getting the same angles all the time. Because now watch, you did this one, if you added 4 pi over 4, you got 7 pi over 4, then you got 11 pi over 4, then you got 15 pi over 4. You're getting the same ones here, 7 pi over 4, 11 pi over 4. You're kind of just repeating it. It is not wrong, but you only need to get one of them to hit the other one. When they're opposite each other, then you're fine with that. Cotangent and tangent will be opposite each other. Because what is their period? It's not 2 pi, right? What is their period? Pi. What is the tangent period? Think back to your curves. It's pi, right? So every pi, I'm going to change. So whenever I have the tangent and the cotangent, it makes it a lot easier. I'm allowed to do this because your period is just pi, not 2 pi. And the only other time that this helps you is when you get a plus or minus and you've got all 4 quadrants. Then you hit this one, which hits that one, and this one, and that hits that one. So the tangent and the cotangent period is half. It's pi. Okay? So you can't. Now here's a typical one that I was just talking about. When you take the square root, don't forget you get a plus or minus. Don't leave it like this, because you'll never resolve this. Separate this out. So you're going to get a plus or minus 2 radical 3. 2 radical 3, if I flip that around, I recognize this. Plus or minus means I'm in all 4 quadrants. So all I have to do is name this one, and then I can go 180 across and hit this one. So pi over 6 plus n pi. Then I name this one, and I can go 180 across and get the other one, rather than naming all 4 plus 2n pi. Right? As long as you're diagonally across, isn't that 180 degrees away? Half of your circle? Mm-hmm. You'll see it more today when we do them out, and we keep adding them today. You'll see it a little bit better. It's a different concept for you right now. And we've been working off the 2n pi, working off the full circle, so it's just a little bit different. Oh, don't tell me this is going to give me grief. I got it got fixed yesterday.
We didn't have to do 34 because it was...
Oh, that's right. I wrote cosine on it. I wrote cosine instead of cotangent. When I was working on that, it wouldn't copy any of my things from when I had that error in it. And I wanted to change them, so I couldn't copy them, so I had to handwrite them. And apparently I wrote it wrong.
Plus n pi?
Yes, yes. Sorry.
For both of them?
For both of them. I probably just forgot that. Plus n pi for both of them. Because you're going to go off your diagonals. Whenever you have a plus or minus, just go off your diagonals. That's the last one, right? Divide. I couldn't take that other one. I couldn't take this guy and divide by move the y here and then divide by y, could I?
There's no plus.
I couldn't do this, right? Even if it was one term. You can never divide and get rid of your variable.
You can't divide by cotangent x and then just
No.
get
No.
cosine squared x equals cotangent x.
You can't get rid of your other one. You can't divide by cotangent. But every time you see something that is decreasing or something on all crazy sides, get them all to one side. Subtract this. The trig functions are a little easier to use 2 different functions, and we'll see that in 1 second. Get this to one side. Now, do those terms contain a common factor? A common variable?
Yes.
But x doesn't go by itself. It's either cotangent x or cosine x.
Oh. Yeah.
So do they contain a similar trig function, the same trig function?
Cotangent.
Cotangent. So let's factor out a cotangent. And what's left?
Cosine
Please
squared.
excuse the interruption. At this time, any student who is performing at NFA North should make their way to the Eagle's Nest at this time. Any student that is performing this morning at NFA North should make their way to the Eagle's Nest. Also, any students who have not yet dropped off their Gartertown trip permissions list should do so immediately. Ms. Kathy and Ms. Guido's chorus students are to report to the chorus room at the end of second period. Thank you.
Okay, so what am I left with?
Cotangent X.
Cotangent, I'm factoring out a cotangent x. If I factor it out of here, what's left? Factor out the cotangent x. I'm not dividing it out, I'm factoring it out. I put it here.
Oh,
So what's left? Minus 2. It's if I did this. Watch. Y, x squared minus 2y equals 0. What can I factor out of these guys? A y. So what's left? It's the same as that. Guys, it's the same thing, right? Now, I could separate these. I could take these now and separate your factors because it's set equal to 0. So I have a situation where the cotangent x is 0 and the cosine squared minus 2 is 0. You did these last year. Yeah, you did. So this one's already simplified. This one we're going to add 2. It works the same as any variable. But remember, your variable is not x. Your variable is cotangent x, cosine x, sine x, secant x. That's your variable. It could be cosecant theta, cosecant y. It could be anything. But that's your variable is attached to your trig function. So now, we square root both sides, and we get the cosine of x is plus or minus radical 2. So let's work on that first. Let's work on that one. Well, obviously that would be all 4 quadrants, right?
Yeah.
So is there such an angle that has a cosine of radical 2? Well, I don't know. Let me drop my triangle and take a look at this, right? All 4 quadrants. So I say cosine is x over r.
There has to be a 45. No,
No, why?
because
Radical 2 is always going to
Radical 2 is always opposite than 90 is the hypotenuse. So is radical 2 larger than radical 1? And what is radical 1 is 1. So isn't radical 2 larger than this?
yeah, and the hypotenuse can't be larger.
And the hypotenuse has to be the largest, right? So is there such an angle that has a cosine greater than 1?
But there is not.
No. So we say reject this.
Oh, that's what it is.
All that for that, yes.
That's not fair.
Yes, but that happens, right? Here's my 1, here's my negative 1. Your cosine goes from negative 1 to 1. So I can't be out of that range. So I don't have an angle. And an easy way to check it is just say in your calculator, second cosine, radical 2. And it's going to say error for some reason. Now, cotangent. Cotangent is x over y. I know this has to be one of my quadrant angles. If you think of your cotangent curve, you'll be a little bit better. Or you just kind of think of where your cotangent can be 0. That would help you as well. 1, 0, 0, 1, 0. So this is the x, this is the y. I'm looking for my x to be 0. This guy, isn't it the opposite of your tangent, right? Your tangent has, it's undefined at 90 and 270, so isn't your cotangent 0 at that point? So my angle is, so pi over 2 and 3 pi over 2 plus 2n pi n is any integer. Okay, that gives me all possible solutions for this guy. Do I have to? In this case, how could I do it then? X equals
Can it just be pi over 2 plus n pi?
plus n pi. Good. Very good.
Wait, so you could just put that, right?
Well, are they 180 degrees apart?
Yeah.
Good. I didn't know if anybody would pick that up. Now, how can I check this? This is an equation. This
Plug
looks
it in.
awfully weird to me. Plug them in. Use 3 pi over 2, n pi over 2, 5 pi over 4 pi over 2, 5 pi over 2. This is my 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi, 5 pi, 6 pi, 7 pi. I can try any of those. Any of my odd ones, right? Just plug it into your equation. Set your calculator in radians. How do I do a cotangent in my calculator?
1 over 10.
1 over tangent. Sometimes your calculator will do 1 over tangent, sometimes it doesn't, depending on if it's going to give you a 0 in the denominator. Then it's going to say undefined or out of the domain or something. It gives you some kind of error. Okay. Let's see if you can get the factors to this guy. Let's make life a little easier. Let's make the sine of x just be x. So let's just call it y. 2y squared minus y minus 1. See if you can factor either way. If it helps take the sign out, take the sign out and look at it with just a variable if it helps you to factor that. That thing is sitting right over the 0. Everybody get a set of factors? Rohan?
So 2 sine x plus 1 and sine x minus 1.
Good. Good. These factors are just 1 and 2. These factors are just 1. So put the 1s out first, and then play with the sign. The sign has to multiply so that when I multiply the larger number by the 1, I'm going to get the negative. If it helps you to do it this way first, and you say 2y plus 1, y minus 1, then go back and put the sign in it, if it helps you to see that better. Okay, so now, again, we could take both factors and set them equal to 0. So let's solve the easy one first. Then I'm going to subtract 1 and divide by 2. So if that's okay with you, I'm going to do it all in one step. Subtract 1, divide by 2. So I have 2 different types of angles. One where the sine is equal to 1, and one where the sine is equal to negative 1/2. First, let's find all solutions, and then let's find the intervals from 0 to 4 pi. So, my sine here is 1. Sine is the y value again. And so forth. What angle gives me a sine of 1? 90. Think of your sine curve. If you think of your curve, I like to think of the curve better than this guy. If you think of your sine curve, isn't it at your 90? Sine of 90 is 1. So pi over 2. And that's all that I get out of this, because at here, it's negative 1. Plus 2n pi, where n is any integer. Now, I get one angle. Listen to me carefully. I get one angle in 2 pi. If I'm going to go to 4 pi, how many angles am I going to end up with? 2, right? So, make life easy. If this is pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, what does this one become? 5 pi over 2. So from 0 to 4 pi, I get two angles. Makes sense, right? I'm only asking you to go to 4 pi. If I added this, if I took this, I would convert this to the same denominator. Look, I would add 4 pi. What is 1 pi and 4 pi? 5 pi over 2. But I only have to go one more time around, so it's easy on the 90s, the 180s, just count. Now, where do I find from 0 to 2 pi, where is sign negative? What quadrants? 3 and 4. 3, 4. Sine, does anybody know the reference angle? 30, right? 30. So this is 6 pi over 6, 12 pi over 6. You were thinking square root of 2. So x, or if you have to, label. Label and you'll see where your reference angle is. So what's this angle that goes up to here? One more than 6. 7 pi over 6. And what's this angle that goes all the way here? 11 pi over 6. And plus 2n pi. Okay, now, I have two angles in 2 pi. If I have to go to 4 pi, how many angles am I going to get? 4. I'm just doubled. Isn't it just another full circle?
Yeah.
So that's a way for you to tell how far you're going to go. So if I'm going to end up with 4, that means I'm going to get another one out of 7 pi over 6 when I add 2n pi. And 2n pi, what do I have to convert to? What denominator? 6. So convert this. I'm going to add 12 to 7. What's 12 plus 7? 19. Okay, then I'm going to start with this guy. I know what I'm going to add. What am I going to add to 11? 12, which makes it what? Because we need to go from 0 to 4 pi. Now, could I do this without that? Sure I could. If this is 0, this is 6, this is 12, what is this guy over here? 18 pi. What is this guy over here? 24 pi. So can I do 1 more is 19, 1 less is 23? If I'm only going from 0 to 4 pi, make life whatever, however easy you see it. I would personally do this. I would just keep adding 6. This is 1 more than 18. If all I'm looking for is these two angles. If I'm looking for more, then I would string them out. If I'm going to 16 pi, I would obviously just keep adding them. So your solution to all of this, from 0 to 4 pi, are all of these angles. This part you didn't do last year.
No, we did not.
But you did up to here. You did up to here from 0 to 2 pi. What you didn't do was add the 2n pi. You always found, and always the regents would say, in the interval from, remember they would say 0 to 2 pi, sometimes they would use 2 hard brackets, 2 soft brackets, sometimes you had to say the 0 and the 2 pi, and they would say it that way. We just changed your life a little bit. Actually, this is a little bit more correct than the other one, but as long as they say from 0 to 2 pi, they were good. So here's my answer. All of these angles
Oh no.
go from 0 to 4 pi. Okay? One more.
Is this, we're gonna have to use sine squared plus cosine
Oh,
squared
good.
equals 1.
Good. You're one step ahead of me, Ashley.
Uh-huh.
Ah. Now, Ashley notices sine and cosine are different. So if I gave you this, you couldn't solve this because it has 2 different variables in it, unless you substitute one out. So Ashley found a way to substitute sine x out. This is your Pythagorean identity. Your Pythagorean identity, guys, on your unit circle, the easiest way to remember this is the value of x, this is the value of y. X squared plus y squared equals 1. X is the cosine. cosine squared plus sine squared equals 1. This is your Pythagorean identity. Without this, you're not going to be able to do a lot of the substitutions. Remember back in algebra they said this is the only one you really have to memorize. So to get sine squared out, I can't take cosine out because cosine's the lowest it could go. To get sine squared out of there, I just solve for sine squared. I'm going to subtract cosine squared. So now, just as if I gave you a y and an or an x to substitute out, you could substitute and make them all the same variable. I'm going to go to my sine squared. I have to keep an eye on this too. And I'm going to substitute this replacement. You can't solve that equation. You can't factor two different variables. And your variable is sine of x and cosine of x, not x. So we can't separate those. So if we replace this, substitute this out, now, don't we have all cosines?
Yeah.
Okay? Watch when you clean this up. Sometimes you got to watch your negative signs. Now, you're on one side of the 0. So let's write this in descending order. My highest exponent is this guy. Then my next highest, this guy. Then I'm going to combine on one side of the equal sign 2 minus 3. What do I get? -1. I'm on one side of the equal sign. You can't add 3, you can't add 2, you can't subtract 2 over here. You're on one side of the equal sign. So 2 and a -3 give you a -1. Now, remember we said we want to factor when this is positive. How do I get this to be a positive? Factor out a -1 or divide everybody or multiply everybody by a -1. It's an equal sign, so I could just bypass the factor and just divide everybody out. All it's going to do is change my signs. And now, find the factors. So find me your factors. This only factors to 1 and 2, so start like that. Cosine x to cosine x. This only factors to 1 and 1. All you got to do is come up with the signs in the middle. When they multiply to give you a positive, but they add to give you a negative, what are your signs?
Wait, what was the question?
They're both negative. When they multiply to give you a positive, but they add to give you a negative, they're both negative. Another way, if it helps you to figure out the signs, take this sign and put it first. Then say, what times a negative gives me a positive? That might help you get the other sign. Now, separate these. You have two factors. And solve for cosine. Cosine x is your variable. I'm just going to bypass this and go to the 1/2. Okay, we're not done yet. Questions? Sarah, you good?
No.
You good? Okay, so we've got two different situations. Let's do the cosine of 1. And this didn't say from 0 to 4 pi, so if it doesn't say, always do the plus 2 n pi or plus n pi. So where on my unit circle do I find the cosine of 1? Cosine would be which value, my x or my y?
I'm sorry.
That's okay.
Zero.
That's okay. Now, only in one spot, right? It's the 0. We're going to leave this in radians. The 0 is the same in radians. Plus 2n pi, where n is any integer. Okay, we only get 1 from there, right? So every time I come back around, 0, 2 pi, 4 pi, 6 pi. Olivia, question?
No.
Now, I go to this guy. A little bit more work on this guy. Cosine is my x value. What quadrant is cosine positive? 1 and 4. All I have to do is label one triangle and I can figure out where my angles are. So this is my 2, this is my 1, this is my radical 3. What's my reference angle? 60. So this is 3 pi over 3, and this is 6 pi over 3. So I've got two angles, pi over 3, and what's my other one? What's that guy? 5 pi over 3. Plus 2n pi. Can I take a shortcut and do plus n pi? They're not opposites each other. So out of all this, I have three solutions. This and this. If you want to just say it once and n equals n integer, that's fine also. As long as you say it somewhere,